Good afternoon. This is Mr. Sadler coming to you live from the internet on Monday, October the 19th, 2015. I'm going to go through two examples today of oblique asymptotes. We'll talk when I get back when the test and the assignment are going to be. I want to be fair to you guys because I know it's not your fault that I've been sick here. I'm looking at probably Thursday for a test is probably when it's going to be. I could push it to Monday if you guys really want, but that would make you have the weekend to forget everything. So assuming that I'm here tomorrow, we're going to have the test on Thursday. So that's what you're going to aim for. If you're gone tomorrow on your religion trip, go to your religion trip, that's fine. I'm going to talk basically about maybe some trig or whatever, assuming I'm back. I pinched a nerve in my neck, so I can't turn my head. That's why I've been gone the last few days. But on we'll do a full review on Wednesday, and then Thursday it looks like will be the test for how that's going to go. All right. So yeah, we'll talk about that when I get back. Today I want to talk about oblique asymptotes. And this was the lesson that I left on Friday, and I got about 4 or 5 emails saying that no one understood it, so I'm going to go through it right now. What an oblique asymptote is it's going to be an asymptote. We're going to say this again. We'll say when a rational function has a higher degree in the numerator than the denominator, it is an oblique asymptote. To find the equation of the asymptote, use long or synthetic division. Okay, we're going to say to graph this, factor everything to get your x-intercepts, vertical asymptotes, and then use an interval chart to find points on the graph. Okay, so let's do an easy example for example 1, and we'll do 2 examples here today, and we'll make sure life is good. Now, for the supply teacher, if there's anything you want to add, feel free to add it. If I'm going too quickly for the class, just raise your hand, and the supply teacher will hit pause, and we'll go from there. Example 1, I'm going to say graph. F of x equals, we'll say x squared minus 9 all over x plus 1. Now this will be a test question. This will be an easy version of the test question. We're going to say using roots, y-intercept, and vertical and asymptotes. Okay, so step 1 is going to be to factor this instantly. Okay, so the way we're going to factor this is I'm going to say, well, the numerator has to factor, the denominator is already done. So I'm going to call this x plus 3, x minus 3, because that's really what my equation is. Let's start with the roots. The way I'm going to sub the roots is I'm going to be solving the equation. I want the numerator to equal 0, so I'm going to get my roots. And we're solving the equation 0 equals x plus 3, x minus 3. Therefore, negative 3 comma 0 is a root, and 3 comma 0 is a root. To get my y int, I'm going to set x equals 0. So that looks like my y int is going to be 0 and negative 9. Okay, if there's any questions here, you can maybe raise your hand and ask the supply teacher, but that should be straightforward. Okay, vertical asymptote. I'm going to have a vertical asymptote at x cannot equal negative 1. Now, there is going to be no horizontal asymptote, okay, and I'm going to try and explain this the best way I can. Using our infinity algebra, if you were to do end behavior or whatever of this graph, if you divide through by x, you end up with x minus 9 over x all over 1 plus 1 over x, which when you sub in would be infinity. Okay, so that's not going to work. So we're going to use long division to find out what the equation is going to be, or synthetic. You guys like synthetic, so I'll do synthetic. So I'm going to do a 1, I'm going to do a 1, 0, negative 9, and this is synthetic division. So this is what I'm doing here, is I'm dividing by x plus 1 to form the oblique asymptote. Let's move down here so you guys can see. Okay, please note you had to put a 0 in there because that's x squared minus 9. Alright, so I'll use synthetic division since you guys like it. The 1 comes down. 1 times 1 is 1. Whoops. 0 plus 1 is 1. And 1 times 1 is 1. And then you have a remainder of negative 8. And that's okay. So therefore we're going to say the oblique asymptote is y cannot equal x plus 1 minus eight over, oh shoot, I screwed up, didn't I? That's why I hate synthetic division. Sorry guys. There should be a negative 1, right? And hopefully you guys are all screaming that out at the TV when that happens. So I'm going to fix that up. Sorry about that. So that should just be x minus 1. Right, because if the root here is for x plus 1, right, when you're using synthetic, that should be negative 1 there. Okay, so this is our oblique asymptote, x minus 1 minus that. Now the thing is, as x goes towards infinity, do I have infinity here? Yes, I do. As x goes towards infinity, 8 over x plus 1 goes to 0. Okay, meaning that we can ignore this part for the asymptote. So what we're going to do is now we're going to make a sketch with the asymptotes. So we're going to put in x cannot equal negative 1, and y cannot equal x minus 1. Now back from grade 9, what this would be an equation with a slope of 1 and a y-intercept of negative 1. So I'm just going to go over to my, whoops, hopefully, lovely graphs here. I'll delete some of these. That was what my grade 11s were doing this morning. Okay, so I'm just going to put my asymptotes on here. So we're going to put, I'll try and use both pages together if I can. I don't know if I can. X cannot equal negative 1. And then we're going to say y cannot equal x minus 1. Now I'm going to make these both asymptotes. So I'm going to make them dotted lines. And those are the asymptotes. Now, as far as this graph on the right goes, okay, the y-intercept is negative 1. It has a slope of 1, meaning you go up 1, right 1, up 1, right 1, up 1, right 1. Okay. So let's go through how we're actually going to graph the rest of this right now. Okay, and I'm going to maybe hit pause, and if there's any question, let the supply teacher ask, or we can talk amongst it among the class. Are we okay? I just want to make sure we're okay where these asymptotes came from. All right, let's go through. Yes, I can make this a little bigger. You don't need to see that this is Desmos.com. So I'll maybe make it a little bit bigger. I should probably go bigger. There we go. All right, so back to this now. Now we're going to make our interval chart. Okay, so I'm going to do f of x. What you're going to use all of your asymptotes and your x-intercepts. So my x-intercept here is negative 3 and 0, and my asymptote is x can't be negative 1. So I'm going to say here then, x is less than negative 3. Negative 3 is less than x is less than negative 1. Negative 1 is less than x is less than 3. And x is greater than 3. So what this is the interval, I should maybe write this here. Interval chart uses your x-intercepts and vertical asymptotes. Okay. So as far as what you're putting in your f of x, it's going to be what you have in factored form. So x plus 3, x minus 3, and x plus 1. All right. So my f of x, I'm going to say x minus 3. And I'll put x plus 3. And I'll put x... I can't remember if it's plus 1 or minus 1. My mind's gone blank here. Plus 1. And then overall and test point. Okay, for my test point, my favorite value less than -3 is -5. My favorite value between -3 and -1 is -2. My favorite value between -1 and 3 is 0. My favorite value bigger than 3 is 5. I'm probably going 100 miles an hour too quickly, so supply teacher, just hit pause if you need to. For the class, remember, just raise your hand if you need a break, and the supply teacher will hit pause. Alright, now I'm just going to sub in the values. -5 minus 3 is a negative. -5 plus 3 is a negative. -5 plus 1 is a negative. So the overall result there is negative. Okay. Same thing, -2 minus 3 is negative. -2 plus 3 is a positive. -2 plus 1 is a negative. The overall result is positive. 0 minus 3 is, whoops, 0 minus 3 is negative. 0 plus 3 is positive. 0 plus 1 is positive. The overall result is negative. And 5 minus 3 is a plus. 5 plus 3 is a plus. 5 plus 1 is a plus. The overall result is a plus. Okay, so I'm going to give you a second to copy that down. Hit pause on the video, please, supply teacher, till they get it. And then we're actually going to graph it here. Okay? So all I know here then is that less than -3 is going to be a negative value. Now the problem is it going to be above or below the 0? Well, we don't know. Okay? Between -3 and -1 is going to be positive. So it looks like probably it's going to go something like this. Okay, that's what I'm guessing. It's going to go through -3. It's going to look probably something like this. All right. In the same way, my other root was at +3, which is here. It's positive on the right of this and negative here, so the values are probably going to look something like this. Did I get a y-intercept in there too? Yeah, I think I did going up here. My y-intercept should have been -9. Okay, so confirming with that, there should be, I'm going to move this up a little bit, so it should be, there should be a 0 here, and go something like that. Let's see what actually happens here. So my equation is f of x, oops, equals bracket x, squared minus 9, all over x plus 1. And that, my friends, is a beautiful graph. Okay, there's a 0 at -3. Okay, to the right of -3 it's positive, and to here. To the left of -3 it's negative. To the right of +3 it's positive. To the left of +3. Now, let's make this a little bit bigger if I can. How do I make this bigger? There we go. If you take a look, there's my asymptote, okay, and that curve goes right along the asymptote here, okay. In the middle, it's not really that close. Okay, right, but as you get bigger and bigger, it goes right along there, and that's what the plus, whatever the remainder was, right? It means in the middle around 0, there's going to be a little bit of a difference, but as we, maybe that's a good distance there, but as you go out there, it's not going to be, okay? Now that is a cool looking graph, and I love it, okay? Hint, hint, test, test, hint, hint. Okay, I'm going to put example 2 on the board. I want you guys to try this. This will involve a cubic divided by a quadratic. Okay, now so you will have to factor this. All right, on Friday I gave a poor example that had holes and all that stuff. I'm going to leave that out of here because I don't want to freak you guys out. This is the level of graph you should be able to do as long as with the next question. Okay, so here we go. Here's example 2. Graph, oops, f of x is equal to x cubed minus 2x squared minus Actually, I'm going to do this one, and then, oh, I won't. I'm not going to scare yet. Well, minus 9 x plus 18. There's something, remind me, there's something I have to tell you or remind you guys of when we get back from, when I come back. Okay, whenever that day is. Let's go to this one, 4x squared. Nah. Sorry, I'm just trying to get a question that'll work quite nicely. So we'll go x squared minus 4x so I'm trying to get one that's going to work out nicely. We'll go for that one. Okay. Alright. Okay, do your best. Notice we're going to say using roots, y-int, vertical, and asymptotes. Okay, so what you start by is factoring. Then what you're going to do is do your intercepts. Okay. Then you're going to use your vertical asymptotes and your oblique asymptote. This is going to be an oblique asymptote because the degree of the numerator is 3, the degree of the denominator is equal to 2. Okay, supply teacher, if you can hit pause right now, I'll give the class a few minutes to try this. Okay, great, we're back. To factor this now, I'm going to use, you can use any way you want, long division, all that. I'm going to factor the top by grouping, so I'm going to use my denominator. I'm just going to call it numerator. I'm going to call that x squared bracket x minus 2 minus 9 x minus 2. So it's going to change into x minus 2 and x squared minus 9, which is equal to x minus 2, x plus 3, x minus 3. Okay, so to go back from what my actual equation is, that was just a side. Oops. This is actually equal to then. X minus 2, x plus 3, x minus 3, all over x minus 4, x minus 1. Alright, let's go for what we know then. Let's start with my x-intercept. That's going to be the roots of the numerator. So I'm going to say x equals 2, x equals negative 3, and x equals 3. My y-intercept is going to be, it looks like to me it's going to be 18 over 4, which is 9 over 2. Okay, excuse me. My vertical asymptote, it looks like, is x cannot equal 4 and x cannot equal 1. Now this is an oblique because the degree of the numerator is bigger than the degree of the denominator. Now this one you cannot factor or cannot divide using syntactic division, so I'll have to use long, and hopefully this works well with the computer here. I'm just going to leave those there to help. So I'm going to divide x squared minus 5x plus 4 into sorry for the poor artwork, x cubed minus 2x squared minus 9x plus 18. I'm just spreading that out so that everything will be lined up properly. Actually, let's go try and move this in. Okay, so this is my division statement. You're looking for the number of times that x squared goes in x cubed, so that's just going to be x. Alright, so going down here, whoops, I'm going to say minus bracket, whoops. Minus bracket x cubed. X times negative 5 is minus 5x squared, and 4 times x is plus 4x. When I subtract those out, I get x cubed minus that is nothing. That's going to be 3x squared. Minus 13x, is that right? Someone confirm that for me? I think that's right. And then this is going to be then plus 3. Sorry for my weird division statement here, but that's the only way I can think of doing it. Minus bracket